as was already said, I'm Emily Birchfield. I'm at the Department of Environmental Sciences at Emory. Was at Utah State, which is where I met Heidi. And I'm really, really grateful to her for this connection and this opportunity. So I'm framing this kind of in terms of food security, but and food security is a really sort of multifaceted, complicated concept and an even harder objective really to attain. But it's about access. It's also about safety and nutrition. And this is kind of what our lab is thinking about at a very high level. But really, we tend to kind of zoom in and think about food security in terms of sustainability and agricultural sustainability. And again, this is probably not news to this group, but this is, in my mind, kind of one of the best definitions of what agricultural sustainability really is and really means for people. And it's this four-pillared definition that I think is really powerful that the National Research Council developed. So yes, agriculture has to satisfy basic needs, but it also has to enhance environmental quality in the resource space. It should be economically viable, which is a very significant problem in the United States, where median farmer income last year was actually negative, which is pretty shocking. And ideally, the agricultural enterprise should enhance quality of life, not just for farmers, but for farm workers and society as a whole. So this is a really ambitious definition, but I think this is the space from which we need to start thinking about agricultural transition. It has to really achieve all of these four things to be viable in the future. So with that in mind, I'm now going to zoom in. We're thinking about agricultural sustainability in this very broad sense, but my lab really to date has been largely focused on this production side of the food system. So we're really thinking about how farmers grow food and how they can be the most productive in their enterprise while also respecting these other sustainability objectives. This is kind of my caveat before I dive in, that yes, the food system is very complicated. Yes, food security is a very broad, multifaceted, complex thing, but we're really focusing on the projection or the production piece of this puzzle. And actually, even more narrowly than that, our lab has really been looking at yield. This is largely because this is how, in the United States, the US Department of Agriculture tends to monitor agricultural health. It's with this fairly simple metric of productivity. And so this is where we can really zoom in and get a lot of data. There's not more robust indicators of agricultural health available at a large scale in our country. So this is really the metric we're looking at. And again, it's narrow. And when you think about really what drives yield, there's quite a number of things that can affect the productivity of a farmer's field, of a farm. And you can see, for example, soil and climate in orange here are really sort of the major drivers of agricultural productivity. We all know this, and our lab's been doing a lot of work looking at how soil and climate affect yield, and in particular, how soil and climate will likely change in the future and affect both where we grow crops, but also how productive those crops can be. So I'm happy to talk a bit more about that research if it's of interest to anyone here. Today, though, I'm really going to kind of zoom in and focus on work we've been doing looking at how differences in land use affect agricultural production. And I'll kind of justify that in a second, but I really want to point out we've been thinking about these drivers of yield, both, yes, to boost productivity, but also to kind of question the extent to which these drivers of yield are sustainable and viable in the future, given that broad definition of sustainability. And we've been really focused on all of these factors that are kind of in gray-blue here, which we're thinking of as actionable, again in quotes, so not all of these are entirely actionable, but actionable factors over which farmers or agricultural stakeholders can exert some level of control. Arguably, age and sex are a little bit difficult for farmers to change, but agricultural policymakers can target individuals in different groups if we know that there are sort of yield differentials by group, for example. So this, again, is just kind of how we're thinking about the drivers of yield. And again, we're focusing on land use, but I'm happy to talk more about our work on climate and soil drivers, which I'll just say, and the models we've been running tend to explain around 70% of yield variability in the US, which is, so it's significant. But these other factors matter as well. That's okay. There's all these social drivers as well. We have a project that we're starting that I'd be really happy to talk about, and I've included some slides on looking at how these factors interact with agricultural production. And so in the Q&A, if we have time, I'm happy to talk about those other projects. Okay, so just a bit of quick data context so you kind of understand what we're working with here. The US is very rich in geospatial land use data. Fortunately, we have this data set called the Cropscape data set that's a 30-meter land use classification for the whole country. So each pixel tells us, with some error, what was planted there in a particular year, or what was occurring in that space. And what's really nice about this data set is that it has a very high categorical resolution for agriculture, meaning it actually distinguishes between, for example, honeydew melon and cantaloupe. So it's this really incredible data set to play with, and it's kind of the foundation of a lot of what I do because it's quite fascinating to look at. So this is a lot of the data I'll be talking about today, and the models are coming from this data set. One of the interesting things we've been looking at is just how is land used in the United States and how is it changing? And so this is just a map I've made where I've computed in a 20-kilometer grid for the whole country, the proportion of agricultural land use. So what you're seeing here is these darker green pixels are essentially showing you places where more of the land is being used for agricultural production. So it's easy to just look at this as an image on your computer screen, but if you step back and think about what this actually means for land use, it's quite shocking. You have entire swaths of our country that are really intensively and exclusively used for agriculture. This is not news to anybody, but the visualizations I think can be quite telling. Some areas that pop out if you're familiar with the United States is the Midwestern part of the country and the area along the Mississippi where we tend to grow most of our grains. And you'll also see the Central Valley in California where most of our fruit and vegetables come from. So one of the most shocking things that you can't see in that image is that half of that land is covered with only 3 crops. And if it wasn't a nightmare to try and unmute and have people guess, you could probably guess what they are. Corn, of course, soy, of course, and wheat. And most of these grains are going to feed livestock. So not only have we radically transformed land use and brought it into agricultural production, the way in which we cultivate is quite simple. We're mostly growing only 3 different things. And I wanted to be fair to my friends out in Utah and the Western United States. If you add livestock to this equation, so you count grazing and pasture as agricultural, this is what land use looks like in the United States. And so you can now see the entire Front Range of the Rockies is totally dominated by grazing and pasture. And so this is really kind of a visualization of land use for food production in our country. And just since I'm kind of framing this talk in terms of food security, in my mind, you cannot talk about food security without talking about this, the ways in which we have radically transformed Earth's surface to grow food. And intuitively, people see this and think, well, I can understand that's probably not great for the environment. And that's generally true. I think this is also not news to anybody in this group, but just as important context, agricultural production is in no way distinct from environmental systems. It's a part of environmental systems, and it depends on these very important ecosystem services to thrive. Climate regulation, things like pollination, soil quality and formation, erosion control. Without these things that are shown here in green, agricultural productivity collapses. And of course, the challenge here is that very intensively managed agricultural systems exert quite a few externalities shown here in red, things like soil erosion, climate change, and greenhouse gas emissions, species reduction. Together, all of these things can actually undermine agricultural production. And so this tight coupling is something that our lab is thinking quite a bit about. And when you see something like this, it kind of begs the question, We know that agriculture has transformed our surface, and we have a pretty good sense that it hasn't been great for the environment. But what our lab has been thinking quite a bit about is what this ultimately means for agriculture and agricultural production. Kind of our slightly biased objective here was to say, hey, if we could show that this agriculturally driven land use transformation, and in many cases land use degradation, um, is associated with yield declines through time or across space, well, that would be some really compelling evidence to try and rethink how we do agriculture in this country. So that's what we set out to do in the project I'm going to talk about today. There's quite a bit of evidence at the field scale, so at the farm scale, that farm level simplification of land use, both in terms of agricultural land use at the farm scale and also non-agricultural land use, decreases ecosystem services in many cases. And again, there's nuance and variety across the type of ecosystem services you're looking at, but it's kind of a general pattern people are seeing. And that in general, this decrease in ecosystem services is good for crop production, but there's mixed evidence because at the same time, farm specialization and simplification can really help to boost yields through more intensive production. And so this relationship, there's a lot of, again, field scale research, but the relationship's a little murky at times. Our lab, we're a lot of geographers, and so we're thinking, well, field scale is important, but scale really matters quite a bit here. And there are really, I think, two reasons for that. One is context. So you could imagine, for example, a very diversified farmer cultivating in a very simplified landscape, or you could imagine the converse, where you have a very simplified farming operation existing in a diversified landscape. And there would be benefits from that landscape, or perhaps negative externalities from that landscape that would affect that farmer's operation and productivity. At the same time, a lot of the ecosystem services that really support agricultural production are often generated very far from the fields that benefit from them. And I'll add that in the United States, when you think about agricultural production, these are generally not sort of smallholder systems. These are massive enterprises. And so we wanted to kind of zoom out and think about what landscape simplification, so focus on that sort of scale of analysis, might mean for agricultural production. And so that's what we set out to do in this project. How might landscape simplification interact with ecosystem services for agriculture and ultimately affect crop production? If you've ever tried to measure ecosystem services across a very large area, you'll know it's very, very difficult. And in the US, there's really not much data available to monitor ecosystem services. So this is something we're thinking a lot about and working on. This is one of the, I think, problems. It's why we don't talk about ecosystem services for ag as much as we should, because we lack the data to do that in a meaningful way. So we've started out kind of looking at this link between landscape simplification and crop production, kind of skipping the ecosystem services piece for now. But again, our idea was, well, if we could establish a link between land use and crop production at a large scale for the coterminous US, so the entire country, that would be compelling, and that would sort of merit further work zooming in. And so that's what I'll talk about today, and then I'll talk about some of our work we're starting where we zoom in. So again, I'm just going to remind you, this is the data set that the research I'm about to show you is based on. It's a, remember, 30-kilometer gridded data set that goes back to 2008. And from that, we've computed a couple different metrics of land use diversity. Here I'm showing you the Shannon Diversity Index, and we've computed these at the county scale for agricultural lands in each county in the coterminous United States. So counties are administrative units within states. They're kind of meaningless ecologically, but they're meaningful agriculturally because this happens to be the scale at which we monitor agricultural production in the United States. So in order to model the relationship between yield and land use, we had to kind of collapse this high resolution gridded data set into a county level version that could play well with the yield data that we're working with. And so what you're seeing here is a map essentially of the diversity of land use in counties across the United States. So darker blue colors are more diverse agricultural systems, whereas lighter sort of yellowy green colors are less diverse. And Shannon Index is a nice one to work with because it looks at both the number of categories in a county, but also their abundance, but also their evenness across space. And so the Midwest kind of pops out as being a fairly simplified region, which is what you would expect. The Central Valley, on the other hand, is very, very diverse. We grow tons of different fruits and vegetables there, so this makes a lot of sense. And my own backyard in Georgia is actually a really diverse space, and I'll show you a little bit more about that in a second. So I'm happy to go into way more detail on what these models actually look like, but this was all of the modeling was Bayesian, and we used a tool called integrated nested Laplace approximation just to help handle the large amounts of data that were involved here. But essentially, at a high level, what we were doing here was we were looking at the relationship between yield for a county year and embedded in a region, which is, so county is I, region is J, and time is T. And we were looking at how a number of different diversity indicators. So we looked at the Shannon Index, the Simpson's Diversity Index, which is a little less sensitive to rare land use categories, and richness, just a count of different land use categories, agricultural land use categories in a county. So that's the relationship we were interested in. But in order to sort of isolate that relationship between diversity and yield, you need to control for a whole lot of other things that also affect yield and vary through time. So these are some of the things that, well, these are the things we threw in the model. We controlled for total precipitation in a growing season, growing degree days, and stress degree days, because they have very different effects on agricultural production. Growing degree days, think temperature exposure that's beneficial to a crop. Stress degree days is the temperature that is detrimental to crop production. We controlled for irrigation, and we controlled for the acres cultivated with the crop in a county. And then I think really importantly, we also have spatial effects that soak up anything about a county that doesn't really vary through time that might affect yield. So think soil type, topography, fairly static infrastructural things, because this is covering only 2008 to 2018. And then we also have these regional time trends, so that anything changing in a region across time would be captured in these effects. And then we also have an error term that accounts for both random error, but also spatially structured error. So again, if you have specific questions, I'm happy to talk more about this in the Q&A, but at a high level, this is what we did. And I'm showing you this just to try and convince you that while this is not causal inference, we really did the best we could to control for as much as we could reasonably control for in these models to really isolate the effect of diversity on yield. So, drum roll, do diverse systems have higher yields? What I'm about to show you is the effect on log yield across the 3 different diversity indicators we looked at. This again is for the entire coterminous United States, so something like 3,000 counties, and across the last decade. And the answer is yes, but it's complicated. So what we tend to see is as counties move from, say, a very low diversity space, so say a Shannon or some of the lower Shannon or Simpson values around 0 or 0.7, and they start to diversify, you don't always see very large yield gains. In fact, in some cases, particularly for winter wheat, you see yield losses as you move from very highly monoculture systems to slightly more diverse systems. Something that we are really excited about and putting a lot of resource into exploring more is that what we do see is as you move from sort of average levels of diversity towards high levels of diversity, so the right-hand end of the x-axis, you see these really significant yield gains. So this is log yield. So you're looking in some cases for wheat and corn, you have yield gains of up to 20% at high levels of diversity, which is counter to everything that we know about how we grow corn and wheat and soy. So the reason we focused on corn, wheat, and soy, I should add, is because, as I showed earlier, these 3 crops dominate U.S. agriculture, but we're in the process of expanding to other crops. These 3 crops happen to have the most data available, but we'll be looking at alfalfa and hay and sorghum and cotton in a project that should come out this fall. So this was something totally unexpected and really exciting. To see that at these really high levels of diversity, we see these significant yield gains. And so I'm going to talk a bit about where we're going next with this work, because for us, the next step was really to zoom in and figure out why. I'll add too, and I kind of mentioned this, is we're we think this is really important. And so we want to make sure what we're saying is legitimate. And so we're doing quite a bit of sensitivity testing right now. We're expanding these analyses to different indicators of land use and looking at, as I said, other crops, so we can see how robust these findings are to different modeling assumptions. So stay tuned, because more should come out in the next couple of months on this. So our preliminary work here has shown, like, yes, with conditions, there may be situations in which land use diversity has a positive impact on crop production. There's still, again, this very complicated question of, well, why? What are the mechanisms driving this interaction? And I think the social scientist in me says, and also, how feasible is land use diversification for farmers? Because if you talk to farmers about when and why and how they diversify, they'll explain fairly quickly that it's very, very difficult to do, and often needs some support and resources to make that happen. So that's where this project is headed next. And this is very much research underway. So what I'll talk about today is very, very preliminary. And I'd love to kind of hear your thoughts on this piece, because we've just secured funding to start really looking at how context affects landscape diversification, how farmers actually diversify, and what viable diversification strategies are across space. And the reason this matters is, I mean, the United States is a very massive space with very, very different typologies of agriculture. The way land is managed is very different across regions. And I kind of showed you that with just the basic map of diversity across space. So this is a really kind of an ugly map, but maybe you get the idea of what we're trying to do here. So this is for corn. All of the gray areas are areas where corn's not grown or there's not yield data for those particular counties. But what we've done here is just quickly thrown together a map that shows you areas that are both highly productive and also very diverse. This is kind of the space in which we want to start doing more research. We're interested, again, in these teal areas, so high yields and high diversity, areas that manage to have a diversity of land use, which there's, again, quite a bit of evidence that this is much better for ecological health than very simplified land use, but also manage to be agriculturally productive. In our mind, these are spaces that are closer to achieving multiple sustainability objectives as compared to really simple and productive systems. And again, SDI is or these diversity indicators are very, 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 very rough proxies for ecosystem health. We're very aware of that. And yield is a very rough proxy for livelihoods and well-being. But when we're trying to do this at a national scale, this is kind of the best we can do with available data. And that's why we're putting a lot of resources into then zooming in particular spaces to see how and why they're diverse and productive. So I've got a student working, Heidi, this is Caitlin who you met, but I've got a student working in the Magic Valley in Idaho, which is very close to Utah State, where Heidi was, which is a really crazy system I'll tell you about in a second, that's very productive and diverse. And we're also rolling out work in Southern Georgia, because this is one of the most diverse and productive spaces in the country for multiple crops. Again, I'm just showing you corn here. And so we're trying to kind of make sense of how farmers are managing land in these places, what they're doing, and how they manage to be so productive for these large commodity crops. So I'm just quickly going to talk about some of our preliminary thoughts on this. This is just a Google Earth clip of the Magic Valley, Idaho. So this is the Snake River running through Magic Valley. This is not so too far from Yellowstone. For context, it's a very, very arid landscape. You can see that here. Everything that's not irrigated is essentially desert. And then there's a whole lot of pivot irrigation. This system is really diverse in a very specific way. So you tend to have these huge farming operations, and within an operation, things are very simplified, but across operations, there's quite a bit of diversity. And this has got us thinking quite a bit about, again, these like viable ways in which farmers could diversify. At an operation scale, diversification is really hard. It means investing in more equipment, more training, more extension, so that you can manage cultivation of multiple crops. But this sort of setup actually brings a lot of benefits, where farms are quite specialized, but across the landscape, there's a diversity of specialization. And so we're thinking a lot about this idea of landscape diversification being this maybe pseudo-intentional, in this case, not so intentional, sort of collaborative way of thinking about what you plan on a landscape to reap the most benefits for multiple stakeholders, while also allowing farmers to be slightly specialized. So this is kind of one case that we'll be looking at. Um, and then this is just a shot of what southern Georgia looks like. So in the southeast, it's quite humid, it's quite wet, and this is kind of what intuitively, I guess we sort of naively thought agricultural diversity would look like, looked at from space, where you have quite a lot of forest cover, and you have these sort of fragmented different fields of different shapes and sizes. And I just know from this particular region, these fields are all growing a ton of different crops. But this is one manifestation. In these large Western systems, this sort of approach may be more viable. Um, so with that, I will stop. I wanted to leave a lot of time for questions because that tends to be the more interesting part of these things. But I'll just say I wanted to sort of thank my collaborators. Kate Nelson is a longtime collaborator who's done a lot of work on this project, and my two students at Utah State who Heidi knows. Britta has a very German name, but she is not German. She's from Pennsylvania. And Caitlin Spangler. So with that, I'll close.